Okay. So, hello. I'm Guilhem. I'm a developer at Berti. So first, what is Berti? Berti is a peer-to-peer application, peer-to-peer messaging application that aim to connect people and send a direct message between them without using centralized server. So Berti is built on top of IPFS, and IPFS is built on top of libp2p. Basically, libp2p and IPFS was not designed to be built on mobile at the beginning. That they aim to, I think they aim to build it, to design it, to run it on mobile. Yes. So we choose actually Go IPFS, not JS IPFS or Rust IPFS. Maybe before, because when we started 4 years ago, firstly there is no Rust IPFS, I think, or at last the Rust version was not ready. So that's why we choose to use Go Mobile. We choose to use Go IPFS. Mainly because it's cross-platform. So with this we can build it on Android, on iOS. Yes, and so basically, the first thing I will explain to you before to talk about libp2p and everything is how we build it at Berti, how we build IPFS at Berti. So first off, we use Go Mobile to build IPFS on mobile. So Go Mobile basically is a wrapper around Go Builder and also a code generator that will generate code for, more specifically, that will generate binding, that will generate file like Objective-C file and Java file to, so you can use it directly from iOS and Android. So it will expose method. Sorry, it will expose method and interfaces. So basically, with Berti, we will expose first an API that we enable us to use it directly with React Native, the client. That will use the API, and then the API will trigger some method in Berti, like for example, simply init the Berti daemon and the IPFS daemon inside. But the most important part for us with libp2p is the second one, is expose interface, because the interface will enable us to implement what we call native driver. So native driver actually use native API, like iOS API and Android API. For example, if you want to implement Bluetooth, you will expose some interface method that you want to implement with Bluetooth, and directly implement with a native API to create a native driver, and then you will register this native driver directly on the Go side. So that's it. Before talking about libp2p, I want to show you the constraint we have on mobile. So it's very important to talk about it, because it's the main concern actually when we develop it on mobile. The first thing I want to talk about constraint is the energy and the performance. So this is a picture of Xcode. It's an image when you run an application and you debug with Xcode. You have what they call energy impact of your application. So this is exactly Berti with running without doing anything. It's like an idle mode, like just that shows a contact. We don't have any contact actually on the application. Just they stay on the main page with all the contact. So the most interesting part in this is on the right side, is the component utilization. So as you can see, the main thing that consumes energy is network and overhead. And you can see also in timeline at the bottom where you can see energy and overhead. So what is overhead? Overhead, this is from the Apple guideline. So it's shared with power and time. So basically, overrate is a consequence of the network. So first when you, since it's from the Apple guideline, actually it's an example, I think, with an HTTP request. We have an HTTP request, so you have a network. So you will trigger, we will enable actually the cellular radio. And then you will shut down you will finish your request, your network request, but the cellular radio will still on. It will still on in case of you will have another network request. So if you see the timeline behind, and actually, if you realize it's a DHT, that it's always active with maybe, I don't know, maybe we have like a 50, 100 connection in this example. But even if it's small pocket that will be sent, even if we don't have a lot of bandwidth, actually the simple fact that you send a simple packet over the network will trigger the radio, the cellular radio. And this is consume a lot of energy, and actually you will see overhead is always active, and it's actually the most consuming part of energy when you develop on mobile. There is another constraint, is the uptime. I think, I don't know which person talk about later, but actually it's a big constraint. Of course, it depends on the application, but let's take Bertie as an example. Bertie is a messaging application, so you don't use it like a lot. Actually, you open it and you close it. So if I do a cycle, it will be actually the state not running state. Then the user opens the application, so you will become in a running state with full capability on your network for approximately I don't know 1 or 2 minutes. That depends on you use your messaging, but basically you just want to send a message or respond, I don't know, but you will not stay a lot on the application. Then maybe you will switch to another application or simply close the application. What I mean by close is really like you just switch from your application to another application, and this is sufficient to put your application in background mode, and then from the background mode you will have like the system will decide when to put your application in suspend mode, like it's like a freeze mode. Actually, they will freeze your application for until you open it. So I say 1 or 2 minutes, but I think it's maybe even shorter. So when you are in a free state, if you have like a connection open, and after you wake up your application, he will still think you have this connection open. So he will have all this connection. Of course, all the peer, if you open your application like 12 hours after you use it, of course, all those connections are already dead. But it takes time for him to know they are actually dead. He does not understand actually. But yeah. So yeah, I think that's it. So the last issue you can have on mobile is, of course, is the cellular connection. In cellular connection, one of the main concerns actually is the stability and the low bandwidth connection you will have. Actually you will be on average you can have a lot of packet drop on cellular connection. For example, you will not have on Wi-Fi. You will have much more stable connection. On cellular, it's like you constantly have a chance to have a packet loss, etc. So yeah, less stable connection. Also, you can have in some country metered connection with a smaller quota. Even if you would like to travel, you don't want like your application can consume a lot of data on your behalf. Also the mobile has this unique particularity of dynamic connectivity. It will switch very frequently between cellular and Wi-Fi, and even with a state of no connection at all. So you need to handle this. You need actually to have a dynamic. Actually, everything is dynamic on mobile. And to finish, you enable to get incoming connection. Of course, when you are in cellular, I mean, not in Wi-Fi and everything, but in cellular, you are enabled to get incoming connection, and this get us on the NAT traversal. So in this part, I will enumerate NAT traversal strategy, especially those on the libp2p. I don't want to explain you what is NAT traversal, but much more. My point is more like NAT traversal with cellular connection. I really want to show you like what solution can work with cellular or not, or maybe. So the first one is universal plug and play. So basically the thing with universal plug and play is to add open a port on your router to forward every packet and, from the outside to your local computer. So you will forward, for example, packet port 4848 to my local port 8080, and you will ask your router to add a rule for to destination port to forward to your local port on your local computer. So this obviously I think doesn't work for on cellular connection, of course. Or maybe I'm wrong, but I think this doesn't exist, not in the cellular world. The second one is hole punching. So basically, in the big picture, the concept is to be simple, to guess your public IP and your public port. So you will ask to a stunt server, what is my public IP and what is my public port, and the other peer will do the same, and this to enable a direct connection between those peers. So this actually we don't really know if it's feasible, but we guess. Most of the time will be like in restricted or symmetric NAT, most of them cellular, but we don't really know because it's really a custom implementation by carrier, by operator. So we can't really know actually if it's always true that it's not possible. We need actually to investigate, but for with our own investigation on like for operator, this never work. Like I said earlier, it's much more because we are very close to a symmetric NAT or a restricted NAT. And the last one, the most simpler, it's the turn that is used by P2P circuit relay. And this one is pretty simple. You connect to a relay and you wait for another peer to connect to establish a direct connection, a proxiate connection with it. So you can communicate with it, and this, of course, works very well on mobile. So this is actually the first thing we'll use on mobile. So, like I said earlier, one of the issues is the dynamic connection. So I will say we have two very specific config. One for cellular, where we'll use actually the NAT traversal strategy. We'll use always turn. In most of the case, we need to investigate, like I say, other method, but most of the time it will be turn. And then we have the Wi-Fi config. And in this case, we will try like UPnP in first place, turn, and then turn strategy. We also in this configuration we also use we decide if we want to enable MDNS. Of course, in cellular connection we don't care about MDNS, so of course it's disabled. And in Wi-Fi configuration, of course we enable MDNS configuration. MDNS, like it say in other talk, it's a multicast DNS, is just to find other peer on a local network. Even if you don't have internet, this allows us to find other peer on the local network. So to do that, we have actually a connectivity driver that is directly bind with a native API of iOS and Android. This connectivity driver simply send a network update. So we catch this network update and simply change the configuration of our libp2p host or IPFS node. And that's it. That allows us to switch between those two configurations. There is another thing that is useful with a connected driver is when we switch from cellular to Wi-Fi or even with no connection at all. Remember, we can also check connectivity of our peer. For example, we can, to do that, actually, the best way is simply to ping your peer, like with an amount of time, and if they respond, they are alive. If they don't respond, they are not alive. The connection is already dead. Next issue with mobile is discovery. So, the first thing for discovery is DHT. So, I will expose the DHT more, but the advantage of the DHT, of course, if it's resiliency and it's censorship resistance. DHT is huge. It's a huge network. If you want to shut down a DHT, you need to kill all the nodes on the DHT. So it's really resilient. But also, DHT comes with a downside, is time-consuming and really energy-consuming, like we saw earlier with the previous picture. When we have a lot of connection, even if it's small packet, it will consume energy because it will enable your cellular radio. It will do the same with Wi-Fi, but it's really, really less consuming in energy. The cellular radio is one of the things that consumes the most energy on your cellular, on your mobile. So, for energy consumption, one of the first solutions is one of the first solutions I'm going to talk. When you have basically DHT, when it's set on DHT server mode on libp2p, it will send requests to the DHT, but also it will respond to requests. So we can gain some bandwidth by put it in the client mode and simply only send requests but doesn't respond to request. Okay. Then for the time consumption, we didn't implement it, but we really want to do that because I think it can be a great idea. We have like we know IPFS DHT is pretty slow because of the warm-up and because you need to, when you find some peer on DHT, it takes some time. So from our experience, using a smaller DHT can be really, really fast and really the warm-up, of course, because the network is smaller. So, for example, in case of Bertie, when we think about custom DHT, so smaller DHT, it will be with, for example, the Bertie desktop. When we can set up a smaller DHT with a desktop with a Bertie desktop, and it can make it faster, for example, to advertise and find peer on this custom DHT, but it's come with the downside is less resilient. So to mitigate this, we're gonna sync our custom DHT with a public DHT. So we have. So our client can connect primary to the custom DHT and fallback eventually on the second DHT. This is not implemented, but I think can be a good idea. The next solution in discovery is a rendezvous service. So rendezvous service is pretty simple. You have a single server. So you just advertise and find peer on it. So it's only one connection is needed on its server. You have no warm-up time and it's instant response, but it comes with a downside because it's a single point of failure, of course, because it's centralized. You really need to see a rendezvous point like a tracker. So that doesn't contain any data, and you can change it very simply. But it's centralized, so that's it. Actually it's very the opposite of a DHT. And then we have local discovery. So local discovery basically enable us to discover peer on a local network. with Bluetooth or MDNS. And when we find this peer on the network, we will exchange topic. So it's really close to what PubSub actually do on the Helio packet. So if we put it all together, we have the rendezvous servers, the DHT public with maybe custom DHT. That can be desktop features, so the desktop Bertie application, and then the local discovery. So to sync all this, in Bertie we have something called the multi-discovery service. So it's one entry point that can reach all those services. It comes with, so when you do, for example, one advertise, it will advertise on each discovery service. So we have different modules on it. We have, of course, a peer cache. So when we call the find peer method multiple time, you will with the peer cache you don't ask too many times all the service, and also it will gather all the addresses and on a peer. So you just have to do one find peer. And then we have the advertise. So the advertise method return a time to live on each service. So we made something to abstract it. I call it a time to live abstraction. So basically, this module will ask each discovery service and return only one static time to live to the user. Also, it will detect every network update, so it can update by himself, advertise again if you have any new address on your swarm or on your listener, I don't know. So you can advertise again on each service. So, connection pool. The next issue, yes, is like I said earlier, it's really hard to have on mobile a lot of peer or too many peer. So we need to be very precautious on this and limit the number of peer on it. For Bertie use case, the entry point of the user is not the content itself, is really to find peer. So we'll have topic that's actually conversation, and every peer will look for this topic to find other peer and to exchange with them directly. It's not like content-centric, but really peer-centric. We want to find other peer on the network to discuss, to exchange with them directly. So I made an example with a repartition of, for example, to limit to 30 connection maximum. For example, we have like 2 circuit relay. That was really important for mobile to connect with other peer. We'll have 2 rendezvous node. That is because rendezvous node is really useful on mobile to be fast. Actually, obviously it's faster than the DHT because it will respond and request instantly on it. And then we'll have, of course, DHT server. So I make an example of 10 node, but it can be more or less. And this is 50% of the routing of our connection pool. And this 50% help us to find the other half that is peer of interest. Peer of interest is really the peer we want to find on the network to discuss with it. So in Bertie, peer of interest is the contact you have on your messenger. And that's it. So there is also other small topic. So I will not discuss this in too deeply. I mean, so yeah, the first small problem we find is Android MDNS that become unusable without specific Java API call. This happened for us especially in Go Mobile. We need actually to not in Go Mobile, nothing, but actually we need to connect to MDNS, to native API on Android to find actually the interface addresses. because actually in Golang, in Golang you can't access the interfaces directly, since I don't know the SDK, but you can access interfaces on Golang. So you need to pass by actually by Android API to find actually those interfaces, to actually use MDNS to find interfaces that support multicast DNS to to actually use MDNS on it. Yeah, on Android, Android DNS request also on Android need to be made through the Java API. This happened on Go Mobile, so we have to actually override some method in Go. It was very painful to do, and without this, actually, you can't resolve any address. There is also lifecycle. I didn't talk a lot about lifecycle, but you need to manage a lifecycle in mobile. Lifecycle will be to be in background, foreground. Actually, you can sum up this with inactive and active in mobile. So where actually, for example, when you switch from an inactive state to an active state, you need, like the connection manager, check if you can if all the connections are still up. Yeah, you need also to make IPFS run as much possible in the background. So to do that, you have some on iOS and Android, you have some API that let you register some time actually to run in the background, but it's not a lot. It's not like 5 minutes or so, and the system decide actually when to run based on the user utilization of your application. So the more the user use your application, the more your application is likely to run often in the background. Handle switch from inactive state. That's what I say. Reuse port. Reuse port is a recent problem we get on libp2p. Actually, when we use it can be in TCP or in UDP, but we discover that on some operator, reuse port just don't work on cellular connection. So it's not libp2p, we can do nothing about it, it's only on the operator side, but it was really painful because we have no error at all. So we just like, it's just you open connection, on about like 30 seconds, connection start to die one by one, and you don't know why. And it's not die actually, it just you just be stuck to read actually on the connection. So but it's depend on the operator. So we need actually in Bertie we disable reuse port. On one thing, for example, in the quick transport, reuse port is enabled by default. There is no option on it. We just discovered it recently, so we really need to add this feature on Quick to enable it again on Bertie. It's really important for us to have Quick on mobile. And yeah, Quick transport is really useful to handle dynamic connectivity or relative issue. Yeah, of course, because you can switch from since Quick is an UDP and a packet-oriented connection, it's really useful to when you switch actually from I don't know 4G to Wi-Fi to keep your connection going on. And I think that's it. Thank you.
Hey. Any question? Oh, sorry. Yep.
Okay, so I have a couple questions. So, let me. Okay, I guess one question would be, have you tried using smaller sized buckets?
On the DHT?
Yeah.
I don't think so. We didn't try, no.
Okay, I think that could be an easy way to get like a small resource thing on the DHT.
What do you mean by a smaller bucket, like to to have less peers simply connected and the DHT or maximum size of the table. That's it.
Yeah. So for like each level of the table, you say store like five peers instead of 20.
No, I don't think so. We touch the connection manager to limit the peer. I don't know, to 50 peer, but even 50 peer, it's a lot. So no, we didn't try to specifically on a DHT to limit the size, but I think that will be part when we will try to optimize the connection pool, like I said earlier.
Cool. Okay, cool. I wonder if the reuse port failing in cellular networks could be an indicator that in those networks, NAT hole punching would fail too.
I think so, but we think that too, actually.
Yeah.
Because before testing hole punching, I think we already know that it will not work. Because when I try to detect this problem of reuse port, I was a server on the client, and I already see on my server that was totally random port and totally different IP. So I'm pretty sure it was like a symmetric NAT. So I think it was already failure. And actually, it was the case because when we tried it, it was already a failure.
And then you probably want to enable reuse port when you're on the Wi-Fi again.
Yeah.
Okay,
That's
cool.
Yeah, totally.
And then I guess like in the dynamic connection scheme, how does the OS present this to you? Like how do you migrate a connection with a peer when you're on cellular and then switch over to Wi-Fi?
How I did what? Sorry.
How does the OS present like you connected to a peer over cellular and then you connected to a peer over Wi-Fi? Like, do you lose the connection and then have to restart it or something else?
Or maybe Antoine, can you? Sorry.
Okay. In fact, the connection just start to hang out totally. You just don't know if the connection failed. You just need to try to reconnect. And the solution we found is to try to ping peer on each update. So when you detect a switch using the connectivity driver, you detect an update in the connectivity. Then you can just start to ping each connection, and after like let's say 5 seconds or something.
5 seconds. Yes, I get the question now.
Okay.
Sorry. So yeah, actually you will send what I did, for example, is to send a ping to every peer actually, and you wait on a given time, like 2 seconds, 5 seconds, whatever, a small amount of time, and every peer that doesn't respond is considered as a failure.
Got it. Okay, cool. Great talk. Thank you.
Thank you.
Yeah.
Hi.
Yeah.
Great talk. I have a question. Since some mobile devices are working as in DHT server mode, actually the application has a lot of churn embedded in it because nodes only live for 1-2 minutes, maximum 5. How do you think the connectivity of your DHT the private DHT would work then?
Actually, when we tried it with a small amount of peer, it was really fast. This we didn't try it actually, so I can say we tried it with a small DHT, but we didn't try the sync and everything.
Yeah, still, but the thing there is, even if it's a smaller network, if you try to have huge buckets or something like that, if you have lots of churn there, I don't think you can ensure the connectivity within the whole network.
Sorry.
No problem.
In fact, we plan to use as a DHT server for the private DHT, so the smaller one. We plan to use the desktop as DHT server, not the mobile. So the mobile will be only client, so they will have a really slow uptime, but the desktop will have a longer uptime. So you don't have a lot of turnover. In fact, we think we don't know, but maybe since it's a messaging application, we hope that people will let their application open for hours, and the DHT can stay up longer. So the mobile will be only client in this mode, but from the test we did on a previous version of Bertie, when we used like a private DHT with a few I don't know, hundred of peer or something, it was really fast. Like I don't know, it's logical. I mean, but yeah.
It was actually like our rendezvous server for now. Like it was really instant, but of course we don't have a big network, so it was logical.
Yeah, because basically right now IPFS DHT on mobile, even if you are only a client, is almost unusable in a real life use case, because when you just open your phone and your app is running for like I don't know 30 seconds or something, you need a kind of warm-up to connect to a lot of peers, and when you have to advertise your peer ID, it will take, you know, and your app is closed, and you didn't even get any peer you need, and you didn't advertise what you need to. So yeah, yeah.
Couple questions. One is the Go runtime providing a lot of problems here? And is there a utility in potentially switching to Rust? Or do you feel happy with Go and that's good enough?
I think if we choose Rust 4 years ago, I think I will be a Rust developer today. Yeah. But now we are with Go. We are happy with Go. It's really cool. It works well, especially in mobile. We don't want maybe there are some problem, but I'm pretty sure if we go for Rust, we will have some problem too. It's not the case, but we are a small team, so rewrite the entire code base of Bertie in Rust is not invisible, invisible for now. Yeah. But why not? But yeah.
Yeah, but no, understood. I was mostly asking, and I don't mean the like rewrite everything in Rust. What I mean is the Go runtime itself can be really expensive for small devices, so it doesn't work well for IoT or anything like that. That's where my question was coming from. And the second question is, did you try? I didn't see lots of gossip sub. I'm wondering if you've experimented a lot with that and whether or not that may be a good way of moving around messages.
The gossip sub.
Oh yeah, actually we use the gossip sub for our group in Bertie, and it's really useful. I think when we didn't have like a lot of big conversation, so I don't know if we use it like I don't know if I am but yeah, we use it actually. I read the spec and everything, so gossip. So for us, I think it's perfect for a group of message. I think it works perfectly for that. Maybe we have something called replication server that aim, but I think I already opened an issue on this. That if we have like a node with a lot of topic, that can be a problem. So maybe some node can have like a special feature to only send because if they send all, if the replication node is goal is to gather all the topic of all the peer of the message of all peer register on it, and can have a lot of topic actually. That's my point. So if it start to exchange, I don't know, like thousands of topic to each peer he cross apart, that can be a problem. But maybe I don't know which one of you I discuss on this. I issue at GitHub to the pub sub justly, but to limit actually the sound of the topic.
Yeah, the hello packet.
Yeah, the hello packet.
Yeah, exactly. We plan to experiment because there is a problem. We need to once again with the desktop, it's not a problem because you have a really high uptime. So it's okay if you have like in a conversation two mobile and one desktop. You don't need to have like a Bertie operated node that will provide high availability, because the desktop itself will be uptime will be up almost every time. So it's okay to forward messages. It will do the job. But in the case of if we need between two mobile to optionally use a replication node, what we call a replication node. So it's a Bertie operated node. A user can add to a conversation. The problem with that is this node will have a lot of topic it listens to, it subscribes to, and the problem is when you connect to a peer using the pub/sub, you will send an hello packet, which is too big when you have a big node. I think the limit is something like 1 megabyte right now in libp2p.
Yeah, I don't know if it's.
Speak in your mic.
Oh, sorry. Yeah, but I don't know if it's the size actually for the hello packet. But yeah, I think it's a limit of size when you exchange a message on pub/sub and libp2p. But I don't remember.
Yeah, so we just need for the replication node to work, which is a requirement for people that will only use mobile and don't have any desktop in their conversation, to like have a super node that can have a lot of topic. And right now it's difficult to do as of today.
So one follow. Have you considered using Gossip Sub to do your peer routing? So you could do peer routing or peer discovery through PubSub.
Like peer exchange and everything, no?
Yeah.
Yeah, we actually enable it, but it's not sufficient to discover the peer on the network. You need, but actually it's really cool. For example, I imagine it on the Bluetooth, when you have a lot of person on the same conversation. That can be really cool to bounce on the peer, and I think it will be really great. But this is another topic, I think. We enable this feature actually. So, but we need anyway the other method to discover other peer. But it's a cool feature, I think, for a big group of person to have this feature to exchange peer on the conversation.
Yeah, and we don't know. We will discuss with you, because you seems to have ideas of what we can do to optimize DHT without, I think, creating like a private DHT, a smaller DHT. And it could be really useful to have your tips on that.
Earlier, you were talking about how like a small DHT is better and like is good performance, and warm-up time is one of the issues you have with like a public DHT. What are some other things that you would need to consider to have improved for it to be a better option to move more towards a public DHT?
I don't know. Really, I don't know. We really use the DHT not for content, just to discover actually peer. We really only use for that. It's only our only concern for now for the DHT. It's to be fast for Bertie, of course. So in the case of Bertie, when you open your app, you want to have a direct connection with your contact and talk with it directly. So actually, our only concern for now was the DHT to be fast. Actually, we wanted to be fast, and that was our only question. So I don't know. But this is, for us, is the main thing we can improve on the DHT is it's to be fast. So
so if the warm-up period was lower, then it would be all right to use the public DHT?
Sorry?
If the warm-up period was lower, then it'd be okay to use the public DHT, like sub 1 second, like to discover other peers?
Yeah, of course. If it's faster, we prefer to use public DHT because of the resiliency and so on. It's just a matter of time. We need to have like a quick access time, and right now we don't know how to do it.
Yeah,
in fact,
that's it.
Great talk. I have a question about discovery, about Bluetooth discovery, and does it work when application is in a background mode in iOS or Android?
So there will be a talk about Bluetooth after, so I think it will respond better than me. But yes, we can. I think we can have on background. The problem is like to run logic on a short amount. I will let Remy talk about this because I'm not confident on it. But for the background mode, I think you can always run background. I will take iOS as an example because it's the most restricted OS for the moment on mobile. But you can always run, I think, for the moment. But I think For the moment, in the background mode on iOS, I don't think there is background like Bluetooth will trigger, wake up your application to do some logical action. So I don't know. For what I know, I think there is much more, like I said earlier, some time that is allowed for you, like to wake up, do something, and then shut down. So, but no, I don't know. I don't know if you can like wake up an application just by Bluetooth because there is near a Bluetooth device near you.
No, you can. Yeah, basically the same rules go. The same rule goes with all the network stack and Bluetooth. It's when your app goes in background, you have like a few minutes before your app gone in suspended mode. So yeah, you can't just wake up your app from any Bluetooth input.
But can you receive notification from that? Like.
If your app is not suspended, if your app was not killed by the system, you can. Yeah, you can be. Your app can be in background mode, and if it's still running in background, you will receive your communication through Bluetooth. It actually works like that on Bertie.
Okay, thank you.
And last question from Yanis.
Hi. More like a comment rather than question. We have run a project where we investigated multi-layer DHTs just to address some of these use cases. So one of the use cases we want to see is what happens when we have local content, and if running a more local DHT would result in faster resolution of content. And the other one is if there is an application that wants to connect their own peers and have access to the rest, but mostly when you're looking for something, check first your local DHT and then go to the other layer. So maybe we should chat. Some of the team that did that is actually here, so it could be useful to you.
Yeah, sure.
C'est le dual DHT au
Yeah.
final.
This is
Ouais, dual DHT, ouais, avec le LAN. We saw that the dual DHT that is available right now on Global IPFS with you have a LAN part and internet part, more global part.
Yeah, so that is the case, but it's the project we did and what has been developed is not on the public release yet. So there is more than that.
Okay.
Yeah.
Okay.
Yeah.
Yeah, we
Might be
want
useful
to know more.
Okay, so now I'm okay.
Cool.
So now